Back at the start of May, I went to a conference in Silicon Valley called Embedded Vision Summit, Durance AI, manned by their CEO, Edgar. Now, unfortunately, I couldn't do an interview with Edgar back in the Valley, but instead, I've got him today on a virtual interview to tell us all about what they're doing at Durance AI, including River, which is a neuromorphic AI platform for robotics and autonomous systems. Edgar, great to have you here. First off, before we dive into any of the questions, Edgar, what is actually Durance, and what do you do at Durance?
So Durance is a French startup. We work on electronics. More precisely, we're designing a chip, a silicon chip. The product is a brain for robots, so an accelerator for embedded AI in robotics platforms. For example, for autonomous navigation, object detection, and probably in the future, vision to action inference.
It's an AI accelerator, so that's almost answered my first question before I asked. But is that an AI accelerator designed to sit next to like a traditional CPU, or how does that work?
Yeah, it acts as a peripheral for a central computing platform, and it is only relevant to, I would say, machine learning algorithm, like it's a compute peripheral.
Right, very much AI peripheral. Traditionally, this kind of system takes like a CPU, GPU, NPU, maybe you have your ISPs, your DSPs. Are you the NPU in this, or tell me a little bit about what Durance is doing in that space?
Yeah, the center of our technology is indeed the NPU, so we're specialized in designing this neural processing unit, which is kind of different from what you may find on the market. And we want to build a full system on chip around it, so using a CPU, interfaces, ISPs, this kind of stuff. Probably no GPU on board, but it can be used alongside a GPU for other types of accelerated algorithms.
AI is quite like a broad term. Are you focused more on like vision, on language models? Tell me a little bit about that.
Yeah, we're more, so for now, we are specialized in vision applications. So this is basically all pre-transformer neural network stuff, like CNNs, ResNets, DenseNets, this kind of old school neural networks. Nowadays, we're moving towards transformers for vision applications, but it's still a work in progress.
Edgar, there's a lot of AI accelerators out there currently in the market. It's a very hot space in edge AI and physical AI. What would you say is like Durance's magic? What's sort of the secret sauce that differentiates you from all the other ones?
So we're not the only one to look for power efficiency, but I'd say our power efficiency is our differentiating factor. And yeah, the most interesting thing is how do we achieve that? And we do that by taking inspiration from the brain. So you might have heard about neuromorphic technology. It is kind of related to neuromorphic technology. Although we don't want to mimic the brain per se, we just kind of really loosely take inspiration from it. And the property of the brain we reproduce in our architecture and in the algorithms it infer is activation sparsity. Like the matrix which contains activations for the network, they're mostly zeros. Only a very low number of elements are actually active during inference. This is what we call sparsity, or more precisely, unstructured sparsity. You may know that NVIDIA, they use sparsity. They kind of turn off parts of the matrix when they do computation, but the sparsity has to be structured in blocks. Our game is unstructured sparsity, so we are able to benefit from zeros anywhere in the matrix, anywhere spatially, but also temporally. And this way we can compute, infer neural networks with much lower number of operations. And we designed a chip that is able to benefit from this unstructured sparsity in the way it processes information. So it is what we call event-based processing. So when we receive non-zero information, the core is waking up, processes this information, and goes back to sleep. And this way, most of the chip is actually idle at any time, which lowers a lot the power consumption of the chip itself.
And so is that really your advantage then? Not because you mentioned companies like NVIDIA, etc. They're doing these structured sparsity, but yours is unstructured. What's the advantage of having it being an unstructured sparsity? What does that mean for an engineer?
Yeah, simply the number of the sparsity is much higher when it's unstructured than when it's structured, because you're kind of non-limited on the sparsity patterns you're able to benefit from. Whereas with NVIDIA, it must be structured. So it's kind of a limiting factor. You cannot increase sparsity as you wish without degrading the efficiency, the accuracy when you're using structured sparsity. But when you're using unstructured sparsity, which is kind of organically present in the network, you're able to reach much higher level of sparsity without degrading the performance itself.
And is that something like defined in your SDK? Maybe let's talk about that. If I, let's say, have a camera vision model that I've already trained in, you know, a standard format, could be PyTorch, Keras, Onyx, TensorFlow, etc. How do I then take that model and then map it onto your custom chip?
So the regular approach is retraining the network from scratch. So this is how we have been working for the past few years. So we have our own machine learning framework, ML ops framework that enables to train networks for this format, like sparse aware networks. But it's kind of a pain for some of our customers in terms of data access and everything. So we are working on automated procedure to convert network, to sparsify existing network. This is still a work in progress. There's still a lot of research to do on this matter, but yeah, we are confident that at some point we will manage to sparsify existing networks. Although I think that in any case, retraining a network from scratch, being aware of the hardware it will be ported on, will always result in better efficiency and better performance on chip.
And so is this something that's going to be applied to, you know, all applications? You know, Edge AI is very broad. You can either have language models, you can have vision models, you can have, you know, audio models. But what kind of applications is your chip, your River chip, tailored toward?
So the killer application we are looking at today is SLAM algorithms for autonomous navigation. So we want to accelerate parts of the SLAM algorithms on our CNN accelerator. That is...
Can you just quickly tell me what SLAM?
Oh, I don't have the exact acronym, but it's self-localization and mapping algorithms. I think it's this one, the acronym. So it's an algorithm that helps to determine the position of the observer and map the environment relatively to this observer. You know, the...
Okay, so mapping.
Yeah, mapping and positioning in the map. And this algorithm, it relies on many different small agents that detect features, perform optical flow, and we want to run as many of those small agents as possible on our hardware architecture for the SLAM algorithm.
Brilliant. And so let's say I'd like to get started. Do you have development kits, demos? What would be my next step if I'm an engineer, I want to try out your chips in my product or system?
So we're a very early stage, so we don't have our own chip for the moment. We're working on FPGA boards, which you find off the shelf, like this one. So this is an AMD FPGA board. And we have the dev kits and everything that's enabled to port your network on this hardware and integrate it in any prototype system. For example, we have integrated it in a Unitary go-to robot for very basic control. There is this dev kit which you can buy, and the SDK that comes with it, and will enable you to play with it. But the chip will arrive itself in mid 27 for the pre-series and probably 28 for the mass production.
What can I expect next from Durance? You know, you say 2027, 2028 is sort of the timeline, and when that comes out, is that going to be something I can purchase, you know, through distribution, or what's your strategy there? How can I get access?
So first, we'll probably print a pre-series, like a few hundreds or dozens of chips, and replace basically the FPGA on this board with our chip. So the form factor and the SDK will be the same, only the accelerator will be the final product. And so you will be able to buy those dev kits from us.
Awesome. Edgar, thank you very much for joining me in this little snapshot interview talk that we've been doing. This is Durance. If you want to find out more information about them, we'll have more links in the description. Edgar, thank you very much for joining us. It sounds very exciting. I'd love to get my hands on it myself, actually.